Good morning, everybody. Hopefully everyone's having a good day, had a good English class. If you can give me a green check mark so I know you're with me, and then we'll get started. Does anyone have any questions from the first 2 pages of the Learning Guide, Unit 6 from last day? If you want to throw those into chat, I could go through anything you had kind of issues with. If nobody had any issues, we'll just move on to Lesson 2 from Unit 6. This one might be a bit of a longer one, so we might fill the whole hour, but at the end, if there's any time, if you have any Unit 5 stuff, I could go through that as well. Reminder that today we have, it's Wednesday today? Yeah, Wednesday, 1 to 3. If you want to come in, get some help on math, or just want to come and do some work, I'll be here. Tomorrow is tomorrow's the Scoop on Poop, a virtual field trip, and then Boy in Striped Pajamas, if I'm not mistaken. And then Friday is archery. And one really cool thing about archery is that we are the first group that gets to go into the new facility that Hardcore Archery is opening up. And I teach with a teacher at KSS. His name's Mr. Begg, and he started an archery program at Rutland Senior. Now he's doing it at KSS, and he's all excited for me. He's like, you gotta go. So I'm like, okay, I'll go. So we're gonna do some archery on Friday. Gonna be pretty exciting if you guys wanna show up. Really easy to get into. All people, shape, sizes, everything. Straightforward enough for everyone to do, and it's a lot of fun. I've done it a few times. My friend has some really neat bows, and I've shot them before, and it's not like a hunting thing. Don't think of it as like a hunting or killing. It's a sport. It's like there's a lot of skill involved and practice and things like that. So it's really easy to get into. Learning curve's very low to get started, and then you can take it or leave it. But I recommend you come out on Friday if you have some time. All right, there was something. Maybe later could we review finding slope in the xy intercept giving one of the values of x or y. We're actually going to spend the whole day talking about slope and intercept. So kind of interesting thing. What else do we have in chat here? Morning, easy stuff. Yeah, this stuff is a little bit easier. I'm going to say Unit 5 was really easy. And then, well, not really easy. Let's not go too far. Unit 5 is a little bit more straightforward. You're looking at graphs and interpreting things. Unit 6 starts pretty straightforward, and then it kind of gets a little bit trickier. A lot of sort of algebra stuff in Unit 6. So not impossible. It's not. Usually students find factoring stuff a little bit more difficult than the Unit 6 stuff. So if you're doing okay with that, you should be all right. But it is definitely a little bit more straightforward, possibly. When's the due date for the test? Unit 5 test, I'd hope you guys would finish by today. But if you need to take another day or something to get that material under your belt, then fair enough. But if you could get it done today, that was kind of my hope. So you've done a lot of slope because your mom really likes math. Well, that's good. And Abby's, you've done it at camp? Can I triangle shaped person do archery? Yes. Even people shaped like triangles can do archery. Mr. Begg was telling me that the bows that we'll probably be using, I think they called them Genesis bows. He said they're like one size fits everyone. So you could be like really big and only have to pull it back a little bit, or you could be like a tiny person, you can pull it back all the way. And he said, they kind of just work for everyone, and it's really straightforward and stuff. So, yeah, and archery at camp, that's fun. I don't know if we'll be using like long bows or compound bows on Friday, but if you've done it before, you can come show us how it's done, Abby, and that would be awesome. We need some experienced bow people, regular little Katniss Everdeens, show us how to shoot some arrows. Let's go into the lesson. I don't think anyone had questions other than maybe looking at slopes and intercepts, and we're going to do that. Alex, safety is our #1 priority. So you don't have to worry about that sort of thing happening. It's like it's a range, so everyone aiming the same direction. It'll be completely safe and fun. We're going to talk about slope, which is kind of weird because when we talked about Unit 5, we talked about slope and intercepts, and now we called it rate of change in Unit 5, but now we're going to talk about it and call it slope and intercepts. So this is a new way of looking at an equation, and eventually you'll be able to just look at the equation and be able to tell what the line's going to look like. So after a little bit of practice. So the slope-intercept form of an equation of a linear function, don't get caught up with all the jargon and the words here. Linear function just means a line, generally. So we're just talking about lines. The equation can be written in the form y equals mx plus b. I'm going to say y is mx plus b a lot. And it is a form of an equation which will, basically if we rearrange the variables in an equation so that they look kind of like y is mx plus b, we can tell what a line looks like just by looking at the equation. So let's define what we mean by m. Last day I said slope was m. I kind of let the cat out of the bag a bit early. So we'll write this as the slope of a line. So m is the slope of a line. And then b is something we haven't talked about yet. This is the first time you've seen it. And I don't know why they use the letter b, but we do. So b is actually going to represent, in this sort of context, the y-intercept. And remember, this is where the line crosses the y, or vertical axis. Okay, so what we're going to do today is we're going to spend time looking at equations and rearranging them so they're in this y equals mx plus b form. Remember, when we have an equation, we have an x and a y, and then the m and the b are the slope and the y-intercept. So if I gave you an equation like y is 1/2 x plus 3, that's the equation that's given here as example 1. This one's already in the form of y is mx plus b. So what does this mean? Well, the 1/2 is in front of the x, which is taking the place of the m. And we were calling m the slope. So the slope in this example, this equation, is going to be 1/2. And then the b, or the number out at the very back here, which we've defined as the y-intercept, we're saying that the b is where this line is going to cross the y-axis. In this case, it's +3. And the positive is important. We always want to make sure we include the +3. You don't have to necessarily write +3, but it's important to note that it is +3. So the negatives and positives are important. So kind of following the instructions that are given next to the graph here, it says, step 1, determine the slope. Step 2, determine the y-intercept. We can just look at the equation, no calculations necessary. Just look at the equation, figure out what's in front of the x term, that's our slope. What's at the very back is our y-intercept. And then we can go from there. So the first thing we're going to do after we've done those things is, first point plotted is the one point you know for sure. So the y-intercept. The y-intercept in this case is 3. So I'm going to plot that point on my graph. I know that the graph crosses, or my line I should say, crosses the graph at 3 here. So I've plotted 1 point. And remember, to draw a line on a graph, we only need 2 points. So we've got 1 point. So we've drawn our y-intercept in, which was 3. Now from the y-intercept, this is step 4 down here, from the y-intercept we can use the slope to plot another point. And what do I mean by that? Well, remember the slope in this case is 1/2, which is the same thing as rise over run. So I can start from my point that I've plotted, and I can rise 1 unit and run 2. That's 1 over 2. Rise of 1, run of 2. That's my 1/2. And I can plot another point. And I can just keep doing that if I want. I have 2 points, that's enough for a line, but I can say, okay, rise again 1, run again 2, and plot another point. Rise is 1, run is 2, I can plot another point. And all of these points will end up on a straight line. So I'm going to take my ruler and I'm going to drop it down here, and I'm going to connect my points with a line. And there we go. So that's the line y is 1/2 x plus 3. So pretty straightforward, I think, generally. One other thing that we can do is we kind of work to the left if we want. Maybe it's not even worth mentioning, but I'll say it anyways. If I have my slope as -1 over -2, my 2 negatives here give me a positive. So what I can do from here is I can say, okay, my rise is -1 and my run is -2. And I could plot the points going down here. So -1, run of -2, -1, run of -2. And I can do that. So if I wanted to plot points going the other direction, I could do that. I've drawn a line through my points, I have a line. So the idea here is you started with the equation 1/2 x plus 3, and knowing that the number in front of the x term was the slope and the number kind of hanging out by itself, the b term, was the y-intercept, we can plot that line. So we've gone from an equation and we've turned it into a graph. So let's kind of do the opposite method here. We've been given a graph and we're going to write the equation of this line. So there's one equation that represents all the points on this line, and we're going to figure out what that equation is. So the 2 things we need to know are the slope of my line and the y-intercept. The y-intercept's the easiest. That's where it crosses the vertical axis. So let's find that first. Look at my line. I see my vertical axis here, and I see that it's crossing down here at -4. So the things that I need to know are my y-intercept. So number 1, locate y-intercept. And in this case, my y-intercept, which I use the letter B to represent, is -4. The second thing I need to do is calculate the slope. Now slope is m, which is the rise over the run. Okay, I need to find a point on my line that goes through like a perfect grid point. I have a few here. I have this one up top, I have another one here, and then I have that one there. So you can pick whatever 2 you want. It's important that we always start at the left and go to the right. So I'm going to start at my first point here, and I can't, if I was going to go to my second point down here, this guy, I have to go down to get there and then to the right. So I know my slope's going to be negative because I'm going down and then I'm moving to the right. So how many points do I have to go down? Well, I'm going down 1, 2, 3. So my slope, I'm going down 3 and I'm going to the right 1, 2. So my slope is going to be a rise of -3 and a run of 2. So the general equation of the line is y is equal to mx plus b. I've said that b is equal to 4, or negative 4, so I'm going to put that in there. And I've said that m is equal to negative 3 over 2, so I'm going to put that in there. And I'm going to end up with the equation of my line, which is y is equal to negative 3 over 2 times x, and then minus 4. I could also write it as y is equal to negative 3 over 2x plus negative 4. If that makes more sense, you want to write it that way, that's fine. So there you go. I have the equation of this line. Pretty neat. I have a line on a graph, and I've written an equation, and I can find any points on this line now, wherever I want. I could say, okay, I have this equation y is negative 3 over 2x minus 4. I could pick, x is 1,000, a huge graph. It'd go on, just be massive, and I could go over 1,000 points in the x direction and figure out what y equals. So now that I have the equation, I can kind of extend beyond the little chart that I'm given in the question. So that is the equation of a line, both starting with an equation and plotting it, and then working backwards, looking at a line and then figuring out the equation. How do we feel about that? Is that okay? Makes sense? Confusing? What do we think? What if it doesn't hit the y-intercept? There'll be examples where it doesn't cross the vertical axis if we have a vertical line. Generally speaking, it's always going to cross the vertical axis, though, somewhere. And the graphs we draw, it'll show up. Sometimes it won't cross at a perfect grid point, like an integer number. It might not cross at negative 3 or positive 3. It might cross between. Those would be some of the examples we do maybe a little bit later where we have to actually calculate where it crosses the axis. But generally speaking, for the beginning questions that we do here, it'll always be an obvious place where it crosses the vertical axis. How do we verify it? How do they want us to verify it? Like, are you thinking maybe like some sort of check to make sure you've got the right answer? I don't know. How would we verify? We could put in a point, I guess, if we wanted. If you kind of like doing checks of your work. The question says to verify it. Oh, maybe I didn't read the question very well. Let's go back. Read the question. Write an equation and verify the equation. That's a good point. Sorry I missed that, Abby. All right, let's verify it. Let's pick a point that's on the line. How about this point down here? I've already circled it. The coordinates of this are 0, negative 4, my y-intercept. So I'm going to plug those values into the equation of my line. So I'm just going to give myself a little bit of room. All right, so remember the 0 is the x and the negative 4 is the y. So negative 4 is equal to negative 3 over 2, and then my x is 0 minus 4. All right, do my bed mass. I'm going to do my multiplication here. Negative 4 is equal to negative 3 over 2, which is 0 minus 4, and negative 4 is equal to negative 4. That is correct. Negative 4 is equal to negative 4. So the equation I've used works. And I could pick any point on that line. I could have gone for, this point right here, which was negative 2, negative 1, and then calculated that and plugged it in, and that would verify that it worked as well. I wouldn't get negative 4 is equal to negative 4, but the left side of the equation would equal the right side. And I guess that's a good enough verification. Okay, we have a bunch of equations of lines here. The first two are kind of more straightforward, and then the next three are kind of special cases. So the first two should be straightforward enough. If you want to think of it this way, just in general, we have the equation of a line is y is equal to mx plus b. So whatever's in front of the x term is going to be our slope. Whatever's hanging out at the back is going to be our y-intercept. So let's figure out what the slope of this equation is, and then let's figure out what the y-intercept is, and then let's plot it. So the slope is whatever's in front of the x term. In this case, I have 1 over 3, and then my y-intercept is going to be whatever's hanging out back, and it's going to be -4. Alex, your question, I think is this maybe coming from the learning guide? We use the, I'm just checking to see if we're going to do any examples like that in class today, and we aren't. So, Alex, what you need to do to figure out something like that, if you have the equation m is equal to y2 minus y1 over x2 minus x1. So you have your slope is 5 over 6, or m, and then you have your points. So you're going to go, we can go a minus, no, we're going to go 14. Let's go a minus 15, and then 14 minus 20. That's where we picked the first term and the second term, x1, y1, x2, y2. And then from here, you can, just do some math, solve for the bottom, multiply to the other side, add 15 to both sides, and you can solve for it. I have a feeling that's from the learning guide, and I'll try to get this stuff done, and I can show you how to do that at the end if we have time. I think we will. All right. So I know my y-intercept is -4, so I'm going to plot -4 as a point on my graph. We'll go with -1, -2, -3, -4. All right, so there's -4. We'll just assume each square represents 1. So my -4 y-intercept, and then my slope is 1 over 3. So remember, slope is rise over run. So I'm going to go up 1 unit, and then I'm going to go over 1, 2, 3 units and plot another point. Now I have 2 points, which is enough to draw a line, but I can continue to go up 1 over 3, draw another point. If I want, I can keep doing that. But again, 2 is enough. So I have 3 here, which should be more than enough. Draw a line through my points, and maybe I'll call this, I'll call it A, just so when I'm done all of my lines, I can identify them. All right, so there's A. Let's see if we can do the same thing with B, letter B here. See if I can figure out what the slope is, and I can figure out what the y-intercept is. Now the y-intercept's a little, it's straightforward on this question. It's just going to be 5, or positive 5. The slope perhaps is a bit tricky because I have this 2. But a slope is usually rise over run. So I guess the trick here is that remembering we can always divide any number by 1 if we wanted to. -2 divided by 1 is still just -2. So for my slope, I'm going to have -2 over 1, and my y-intercept, I'm going to have positive 5. So let's plot this line. First thing I do is find my y-intercept. 1, 2, 3, 4, 5. Plotted my point. Then I'm going to use my slope from that point. I'm going to go down 2. So there's 1, 2, and then I'm going to go over 1. My slope is -2 and over 1. And I can keep doing that again and again and again, but I don't need to, so all I need is 2 points. So I'm going to connect those points with a straight line. All right, so that was letter B. C, D, and E are all kind of exceptions, I suppose we could call them. They all have something a little bit different about them. So if I look at letter C, what am I missing with letter C? There's just something that's not there. And what does that mean for my line? So remember, the general equation for all lines is y is mx plus b. But I don't have something. I don't have plus b out at the back. There's just nothing there. So what does that mean my b is going to be? So I know my slope, m, is whatever's in front of the x term is going to be 2 over 3. But what about b? What is that going to be? The y-intercept is b, but there's nothing there. So how do I represent, or how do I find what my y-intercept is then? If there's no term there, I don't have the plus b out back. What can we just assume that the b is in this case? Yeah, we could just say b is 0. There's nothing there, and we use 0 to represent nothing. So that means that it's going to cross right in the middle. My y-intercept is 0. If I had 1, it would look like y is 2 over 3x plus 1, which is different than y is 2 over 3x. So if you want to think of it as y is equal to 2 over 3x plus 0, that would be the same thing. So there's nothing there, it's just a 0. All right, I'm going to use my slope now. I'm going to go up to 1, 2 over 3. 1, 2, 3. I'm going to end up there. I'm going to go up 2 over 3. End up there. Okay, so I have enough points to draw a line. That would be letter C. Now, letters D and E are going to test your memory from last day. We drew lines last day. We had 4 lines. We had one with a positive slope. That's a negative slope for you guys. One with a positive slope, one with a negative slope, and then we had a vertical line and a horizontal line. And we said one of them had a 0 slope and one of them had a slope that was undefined. So those are the 2 scenarios we're going to run into here. So letter D, I don't have any x. There's no variable x in there. So what does it mean in terms of my equation of my line? Something is missing. Again, this is one of these scenarios where you can think of it as y is equal to something plus 7. If you want to think of it as 0 times x, you could. But we need to still come up with our m and our b. So our slope, it's gone. There's nothing there. So that means because that x term is missing, the x is 0. Because 0 times whatever the slope was is 0, and that's there. So the slope is going to be 0, and the y-intercept is going to be positive 7. What did a slope of 0 look like? Was that a vertical line, or was it a horizontal line? So we're going to have to plot it, and I have a y-intercept to go from, but I need to know, do I draw a vertical line through my y-intercept, or do I draw a horizontal line through my y-intercept? Hopefully you're frantically flipping through your notes from last day. 1, 2, 3, 4, 5, 6, 7. All right, so there's my y-intercept up at 7. What do we think? Vertical line? Horizontal line? What do we have here? Slope of 0 is horizontal, vertical is undefined. So I have said that my slope is 0. I don't have the illegal vertical line. All right, so slope of 0 is a horizontal line, and I know my y-intercept is 7 because I had that y as 7. If you want to think of it that way, or you can just say the equation is y equals 7. It doesn't matter what x is. X can be anything, but y is always going to be 7. If you want to think of it that way, because it's just the equation, y is 7. That is not a very good line for y is equal to 7. I'll try one more time. I'll give up. It's better. So this is line D. Y is equal to 7. Doesn't matter what x is, y is always going to be 7. X could be 2, y is 7. X could be negative 1,000,000, y is 7. Just doesn't matter. There's no x term there, so y is just always going to be 7. Okay, the last one, letter E, is the tricky one in the bunch, I guess. It is x equals. Running out of colors here. Maybe I'll draw a bit of a thicker blue line. Okay, so remember we have to have an equation in the form y is mx plus b. But we don't. We have just x is equal to 6. In this case, negative 6. So do I have a y is equal to mx plus b scenario? I do not. I know x is equal to negative 6. I don't have an m. That's just not there. There's no number in front of my x. So because it's not there, we say it's undefined. And b, I don't have a y-intercept. I'm not going to cross the vertical axis. Why is 0 divided by 0 not 1? Because we can't divide by 0, ever. You just can't do it. It's undefined. So this is kind of the opposite scenario of the previous example. We looked at y is equal to 7. Doesn't matter what x is, y is always equal to 7. Same thing here, except x is always negative 6. So I'm going to find negative 6. 1, 2, 3, 4, 5, 6. It doesn't matter what y is, x is always going to be negative 6. So I have, this is line E. So it's a vertical line. The slope is undefined. There's no m term there. And then you have no y-intercept either because it's just x is equal to something. So it doesn't matter what y is equal to. X is always equal to negative 6. Y could be 5. X is negative 6. Y could be 1,000,000. X is negative 6. It doesn't matter what y is. It's just going to be x is negative 6, just a vertical line. So somebody asks Siri. Is that what we've gone to? Just asking Siri for answers to questions? Okay, example 4. We're doing okay with time here today. The equation of the line is y is equal to 3x plus b. Determine b when the line passes through the point. So what this question is saying is, if I don't know what the b term is, but I do know that it goes through the point negative 1, 1, can I figure out where it crosses the vertical axis? So the idea here is find b, or find the y-intercept. That's what the question's asking us to do. Okay, so there's two ways to do it. You could do it graphically. You could plot it on the chart and then use your slope. Or you could do it algebraically. So if you didn't want to draw a graph, you don't have to. It's completely up to you. I'll give you both. Let's start with the graph first. So it says the point C, negative 1, 1, is on my line. It says the point goes through here. So this is negative 1, 1. And I know the slope. From the equation of my line, the m value here is 3 over 1. Because that 3 there is divided by 1, if I want to think of it that way. So I can go with my slope, rise over run. I can go up 3, 1, 2, 3, and I can go over 1. All right. That just so happened to line up exactly on my y-intercept. I can do it again if I want. I can go up 1, 2, 3, over 1, draw another point. There we go. So I'm going to draw a line here to connect my dots. The question's asking me to determine the y-intercept, so where it crosses the vertical axis. It looks like this is happening at 1, 2, 3, 4. B is equal to 4. So that's using my graph. That's one way to do it. The second way to do it is using some algebra. So I don't have to plot a graph if I don't want. I can just go with the equation of my line as y is 3x plus b. And I know the point negative 1, 1 is on the line. So the first ordered pair here, the first item in my ordered pair is negative 1, so that's going to be x, and then y is going to be a positive 1. So what I'm going to do is substitute in positive 1 for y, and then I'm going to put in negative 1 for x, and then I can solve for b. Run out of room here. So I get 1 is 3 times negative 1 plus b. 3 times negative 1 is negative 3. Then I'm going to add 3 to both sides. And I end up with 4 is equal to b. So because that point, I knew it was on the line. The question said, hey, this point, negative 1, 1 is on the line. You can plug that point in to the equation and figure out any missing variables. So there's two ways. You can graph it, figure out where it crosses the vertical axis, or you can plug the point in and then figure out algebraically where b is. The next question is almost exactly the same, except it's asking us to find the slope instead of finding the y-intercept. So let's continue on. Y is equal to mx plus 2, and it wants me to find out what m is. So we're looking for m. Again, two methods for doing this. I can either graph it or I can solve it algebraically. So let's go with algebra first. Maybe change it up a bit. Y is mx plus 2. I know my point is 5, negative 5 and 1. So I'm going to substitute those values in. 1 is equal to m times negative 5 plus 2. Okay, so I'm trying to figure out m. I'm going to try to get m all by itself. I'm just going to rearrange how this is written. 1 is equal to negative 5m plus 2. I'm going to subtract 2 from both sides. 1 minus 2 is negative 1. Negative 5m, and then I'm going to divide both sides by negative 5 to get the m by itself, and I end up with negative 1 over negative 5, which we'll just call 1 over 5 is equal to m. So the slope of my line is equal to 1 over 5. The second method is plotted on the graph. So I can say, okay, I have a point, negative 5, 1. Let's find that point. Negative 5, I go down to the left, 1, 2, 3, 4, 5. I go up 1. So there's my point, negative 5, 1. And I know my y-intercept, in this case b, is equal to positive 2. So I have another point there. I could draw the line between those 2 points. And the whole idea here is that I'm trying to figure out what the slope is. So I need my rise over my run. How far do I have to go up? Well, I'm going up 1, and I'm going over 5. So my slope is 1 over 5. Rise of 1, run of 5. Two ways to do the question. Sometimes it's going to be easier to draw a graph. Sometimes it's going to be easier to do it using some algebra and substitution. And sometimes you won't have a choice. It'll say, using substitution, figure out what the slope is. Or using a graph, figure out what the slope is. So sometimes you have a choice, sometimes you don't. We doing okay? The graph is better? Yeah. When it's really nice numbers, the graph is better if everything's kind of working out as an integer, and most things will. You'll get into some maybe like word problems where all of a sudden you need to find the y-intercept and it's not a whole number like 2. You're going to end up having a decimal and it's not going to be as easy, so you might have to do it algebraically because you won't be able to, like given a really small graph and you're between 2 points, you're going to run into problems there. No, Alex, it's not. It's on your formula sheet. It's m is y2 minus y1 over x2 minus x1. Looks like this. And that is, there was like a shaded in box from the lesson last day with this stuff on it. And it'll be on your formula sheet as well. It's 2 places to look for it. Okay, so this is kind of taking this a step further into kind of like a word problem. So this really looks like stuff from the last chapter, chapter 5, but a little bit different. So we're gonna figure out what's going on in the graph here, dependent, independent, same sort of stuff from the last unit, a little bit of new stuff. So the graph below describes the cost to rent a car. And we've talked about this a bit. You have your y-intercept here, which means something. You're going to have a slope, which means something. We're going to figure out what all these things mean. So the dependent variable and the independent variable. The dependent variable is going to be on our y-axis, which is cost. So how much the car costs. The independent variable, the thing that it's going to determine what's going on in our question here is the distance. And in this case, it's how many kilometers we've traveled. Slope and rate of change are very similar. It's a really good question, Abby. Slope and rate of change are almost the same thing. They're calculated the same way, but when we talk about rate of change, we want to know how much it costs per 1 kilometer. So I could say the slope of the line is, 20 over 2. That's the slope. But it's not, it'd be like $20 per 2 kilometers. It's true that it's the slope, but what is the rate of change? Well, it's $10 per 1 kilometer. So you always want to get rid of the denominator. I don't know what the slope of this line is yet. I haven't got that far. So the rate of change is the slope, but in simplest terms. So the slope over 1. I don't know if that makes sense. Hopefully it does. According to the graph, what is the slope? So we can look at the slope using many different things. We could, find 2 points, use the slope formula. We could just go rise over run. If it works out, we can go from there. So maybe let's just start with rise over run and see if we can determine the slope. So I'm going to look for perfect points where it crosses, perfect grid point. So I have one there, I have one there, I have one there, I have one there, and I have one there. So I can pick any one of these and go from there. Maybe I'll just use this guy here. So I'm going to pick this one. I'm going to say my slope is my rise over my run. And I want to read it like a book. I'm going to go from left to right. So if I start at my green circle here, how much do I have to rise to get from here to here and then run from here to here? Now, one thing we need to be careful about is the squares on this graph don't represent 1 unit. This is 20 here, 40, so this is 60, 80. So I'm going from 60 to 80. So my rise is actually $20. And my run, I'm going over 2 boxes, but in this case, these 2 boxes represent a run of 100. 20 divided by 100, 20 goes into both 20 and 100. So 20 goes into 20 once, and 20 goes into 100 5 times. So I have a slope of 1 over 5. That is my slope, but that is not my rate of change. And I think this is kind of maybe what you're alluding to, Abby. The slope represents in this equation. So I guess you could say it costs $1 to travel 5 kilometers, but you don't want to write that because that doesn't necessarily, well, I guess you could write it. So the slope represents cost of, the top is $1 to travel 5 kilometers. So the rise was $1, the run was 5 kilometers. We could also write that as a rate of change. Just making sure that that isn't a question that we're going to answer later. Maybe help you out a little bit, Abby. The rate of change in this case is 1 divided by 5. So 0.20 dollars per kilometer. So the rate of change is 20 cents a kilometer. The slope is $1 for 5 kilometers. So if I just take that 1 and divide it by the 5, 1 divided by 5 gives me 0.2. So that's kind of the difference between rate of change and slope. Although they're really closely related, they're essentially the same thing. Well, they are the same thing. Usually we represent rate of change as just divided by 1 or over 1. Okay, so that's the first 4 there. According to the graph, what is the y-intercept? It looks like I've circled it and I've written the number next to it. So the y-intercept is 60. And this is kind of getting into this idea of what does this 60 really mean? It's $60. And what can I do to kind of describe this to a 5-year-old? $60. What does that mean? You go to rent a car. You pay for the car rental, $60. And then you're going to pay more after you've traveled some distance. So this is the initial cost, I guess. $60 is the initial cost to rent the car. And then it asks, what's the equation of the line in slope-intercept form? And slope-intercept form is just what we've been talking about. So I know the slope is 1 over 5, and I know that the y-intercept, in this case, is 60. So if I were to write an equation, I'd have y is 1 over 5x plus 60. And that, again, is in the form y is equal to mx plus b. So thinking of each square as representing 1 is a really common place where students will get a bit mixed up when talking about graphs, both in chapter 5 and chapter 6. It's important, especially in the word problem type things, to look at what is actually happening on the graph. And I mean, the sad thing about it, I shouldn't say sad, the disappointing thing about it is you know what you're doing everything correctly. It's just that you fail to recognize that, one square on the x-axis is 50 kilometers, and then 2 squares is 100 kilometers. So don't always assume that each square represents 1. It very often is the case, but it's not always the case. So it's good to make that mistake here as opposed to on a quiz or a test. The last couple questions here. How much would it cost to travel 1,000 kilometers in this car? So the distance is on the x-axis, the horizontal axis. basically what this is saying is x is equal to 1,000. So you have your equation. Y is 1 over 5x plus 60. And now we're putting x is 1,000 into the equation and solving for y, or the cost. So we get y is 1 over 5 times 1,000 plus 60. 1,000 divided by 5 should give us 200 plus the initial cost of 60. So in this case, it costs us $260 to travel that distance. Each kilometer costs 20 cents if you want to think of it that way. 1,000 times 20 cents. You can go from there. Okay, now I was thinking square. I actually used unit conversion to do h. Is that okay? How much would it cost? Yeah, you might run into problems with the initial cost, but if you've accounted for that, then that's fine. The last part of the question, it says the cost was $12 or $300. So this is saying the cost, 300, which we're calling y. It's 300. So if we take our equation again, y is mx plus b. Our equation now is y is 1 over 5x plus 60. And it's saying, okay, the cost was 300. How far did you go? So 300 is equal to 1 over 5 times the distance plus that initial cost of 60. So we're going to solve for the only variable we have left, or x. So I'm going to subtract 60 from both sides. I'm going to get 240 is equal to 1 over 5 times x. Multiply both sides by 5 to get rid of the fraction. And 240 times 5 is going to give me 1,200. And in this case, this 1,200 is 1,200 kilometers, is going to cost $300. So there you have it. That is the slope-intercept form in a nutshell. Alex, did you sort out that question you'd asked earlier with the slope equation stuff? Just want to make sure you kind of wrapped your head around it. Maybe while I take a peek at the learning guide, you can tell me if you got it sorted out. So the slope formula stuff, question number 6 would have been, you got it, perfect. Question number 6 kind of would have been what Alex was talking about. Slopes of the lines, you guys should be masters at this stuff now. And given the slope of a line and a coordinate, 2 other points on the line, find the unknown value. So Alex was doing a question like this. He was a bit ahead of us. So we're using the slope formula is y2 minus y1 over x2 minus x1. What you're doing is saying, okay, the slope is 5 over 6, and then you're picking points. So this is x1, y1, x2, y2, and then plug them in. So y2 was a, which I'm trying to find, minus y1, which was 15. And then x2 was 14 minus x1, which was 20. The order doesn't matter. If you called this your second point and this your first point, you're still going to end up at the same spot. So your signs will be flipped, but it'll all work out. So you can do that. And then the idea here is that you're going to solve for a. I'll have some time to do some of those next day if you guys have a few questions about them. So we should be good there. Number 10 is really similar to the stuff we've been doing, except it says a slope of 2. Remember, -2 is -2 over 1. So you might want to just change that. Might make your life easier. Slope-intercept form, you should be good. Number 4 is just asking you to rearrange it to get it. So you're going to solve for y. So you want it to look like y is equal to mx plus b. So that's the trick there. Number 5 and 6, we did examples like that. Number 7 should be good. So we didn't do parallel and perpendicular lines, so this is the end of lesson 2 here, midway through page 5. So lesson 2 will take us that far. I'm going to leave it there for now. I'll have time, lots of time tomorrow to answer questions, and we'll do lesson 3. Hopefully you can finish the Unit 5 exam today. I noticed a few more Unit 5 learning guides have trickled in. If you need any help on any of this Unit 6 stuff, anything from Unit 5 or before, I'll be available today from 1 to 3. Hopefully we'll see some of you here. And we have a movie on Thursday and archery on Friday, which is going to be very cool. So hopefully we'll see you in the next couple days. If not, I'll see you online tomorrow. Thanks.